Okay, YouTube, in this application of linear systems, we're going to look specifically at an example in which we're going to set this up geometrically. And so let's go ahead and start by reading the problem and discuss what it is that we want to find. That way we can move on to defining our variables here. But we would say that we have a rectangular lot whose perimeter is 200 feet and is fenced along three sides here. So we have 200 feet of perimeter. I'm going to go ahead and underline that here. And it's fenced along three sides. We say an expensive fencing along the lot's length costs $30 per foot, okay, and an inexpensive fencing along the two side widths, okay, cost only $10 per foot. We notice that here it says that the total cost of the fencing along the three sides comes to $2,600 here. And what we're interested in are what are the lot's dimensions. And so let's go ahead and start with defining our variables here. When we talk about the dimensions here, we're going to say that this is a number of something that we're trying to find. Now, talking about dimensions, what we're being told here is that we have a rectangular lot. And so kind of imagining this lot as being a rectangle here. And I'm going to put this actually in two different colors here because I was told it was fenced along three sides. I suppose that we're told that these are the dimensions. And so in terms of dimensions, we have width and we have length. And so I'm going to go ahead and interpret the width, okay, as being these two sides right here. And so we would say that the width, in terms of the width, I don't know, why don't we call the width x, and we'll call this here a y. But what we could see is that we have x equaling the number of what along the width of this, and what are we measuring this in? We would say, well, the dimensions there are coming in packages of feet. So we say the number of feet along the width, okay, along the width. And then this likewise would be the number of feet along the length. Now the interesting thing about this, as we set this up, now that we have these defined here, is that we were told, okay, that the rectangular lot has a perimeter of 200 feet and that it's fenced along three sides. And so let's go ahead and take a look at this perimeter of 200 feet business. Now with respect to perimeter of a rectangle, recall that when we talk about a rectangle, if we're going to call this the width here, we're going to call this the length, okay, that's an L. Then we would say that the perimeter of this really is twice the length plus twice the width. Okay, so with respect to what we have right here, we could say that, well, since the perimeter is 200 feet, then it must be true that if we were to take 2 times x plus 2 times y, we would get 200. Now the interesting thing here is that we're told, and this is kind of the weird thing about it, that it's only fenced along three sides. So even though it's only fenced along three sides, we would say then, well, you still have 2x plus 2y being the perimeter. That's 200 right there. So in terms of our system, one thing I do want you to notice is that this 200 is in feet. Well, so are these right here. And so we would say 2 times the number of feet in the width plus 2 times the number of feet in the length here is the total number of feet around the outside of this, or around the perimeter. So we can kind of check this off here. We've gotten rid of our feet equation. I'm going to go ahead and write this over here. We say this one was in feet. Now in terms of other units, it looks like we're measuring some numbers here in terms of dollars. And so that dollars right there, just to emphasize this, it represented a cost. And so we're going to come up with what we call a cost equation. And if you're not picked up on this yet, let's go ahead and pick up on it now. Essentially what we keep seeing is that we have something x plus something y equals something in a lot of these problems. And so of these three values right here, I would be inclined to say that the total cost should go on the right side of this. And if we're going to set up in a relationship here that represents the cost for each of these, then we would say that it's $30 per foot along the length. So we would say $30 per foot along the length, and it would be $10 per foot along the width. And so when we look at this here, we could really say that if we were to take the number of dollars per feet times the number of feet, then we would come up with the total number of cost here. And so what we'll say is essentially this. We would say, well, how many feet do we have in terms of a width direction here? Now you'll notice that we actually have this x here and this x here. So how many total feet there are? We would say that there are 2x feet. And so the weird thing about this is we're going to say that if we took 2x times the cost per each one of those feet, then we would say this is our length times the cost per length. And then for our y here, we would say it's $30 per foot times the number of y's here. So we would say y times $30 per y would come out to be this here. So we're going to have to clean this up a little bit here before we solve our system. But what we get is this first equation, 2x plus 2y, which represented our perimeter here. was 200 total feet. And then with respect to these, we get 20 x's plus 30 y's coming out to be 2,600 here. So in terms of elimination or substitution or addition or substitution, I would be inclined, since I don't have any positive 1 coefficients, to just go ahead and take this first equation times a negative 10. And so what we would get is a negative 20x in front. We'd also get a negative 20y, and I suppose we would get a negative 2,000 here. But we would have that 20x here in our second equation canceling out with negative 20x in the first equation. So rewriting this system then, what we end up with is our x's canceling, and we look at these y's coming out to be 10 total y's, 10 y's, and that would be equal to 600. So what this would imply is that y must be 60, and so we're going to say that our solution here, okay, has a y value on its ordered pair of 60. So let's go find our x value. Because we know that 2x plus 2y is equal to 200, and this is our smallest scaled equation, what we'll do is we'll go ahead and substitute in for the value of y now what we know its value is, so 60. And so what we end up with is 2x plus 120 is equal to 200. Well, subtracting 120 from both sides, what that does is leave us with 80 on the right side here. And so if 2x is equal to 80, then all of a sudden we've developed the fact that this is 40. And so this is 40. So in terms of the original context of the problem, where we said x was the number of feet along the width. And so what we would say is that x is 40 feet in width, okay? That's one dimension. And then we say y is equal to 60 feet of length, okay? And in terms of the original context of the problem, if we were to go back in and put our 60 feet up here, and for each of these put in 40 feet and 40 feet, then what we would see is adding these up here. We get 40 plus 40 is 80, okay? And 80 plus the 60 here, suppose 80 plus 60 is 140. If we were to add on another 60 for this side, then the perimeter truly would be 200. And if we were to actually do this, take 40 times $10 per foot, times, plus another 40 times $10 per foot, plus 60 times $30 per foot, we would indeed get 2,600. Cheers.